Welcome back to CCNA 2. We're going to talk about configuring a DHCP server on Cisco iOS. So this is the diagram we're going to be using. We're going to have two different networks. And now you'll notice they're on different sides here of this router. Now remember, DHCP uses broadcasts, and broadcasts cannot traverse routers. So we have to use a device on the subnet that we're giving DHCP to, unless we use this special command, which we'll talk about, to redirect those broadcasts. So we'll use this DHCP server on the router here so we can access both networks natively. So we really have a three-step process here. First, we're going to exclude addresses. And this is important to do first because you don't want to hand out an address and then exclude it later. You'll end up with just a mess on your hands. So the first thing we want to do is use this command, IP DHCP excluded addresses, and then whatever addresses you want to skip. Then we'll create a pool. So you can do that with the IP DHCP pool command, and then you just add whatever pool name you want. Usually you would use like maybe a VLAN number, like the pool name would be VLAN 30, or maybe it would have the common name of that VLAN like cameras or IP phones. So then you're going to configure the DHCP pool itself. We can do things like what are the addresses in that pool with the network command, right? And this is just like we would normally configure a network within maybe a routing protocol or on an interface, except for it would be a range, not necessarily a one like we would have on an interface. Default router and gateway, same thing, right? Default router and gateway. Usually you'll want this on most networks. DNS servers, again, you'll want that on most networks. Domain name, which is optional really. If you want to have a domain name, define the duration of the DHCP lease. So we could say how many days, how many hours, how many minutes, or infinite, which usually you don't want infinite. Define the NetBIOS or Win server. Now usually you won't use this very often, hopefully. This is what the whole example will look like for. It looks like 10, so it'll be this network over here we're doing first. So first we'll exclude these two addresses. It looks like this first one's a range here. So maybe we have some static addresses in the 1 to 9 range, and then 254 is probably, it's not our interface. Nope. Okay, well we're excluding it for something else. Then we'll call this one LAN 10 DHCP pool. Now I would prefer a much shorter name like VLAN 10 or LAN 10 even in this situation. Making it so long like that makes it tedious to remember, to type in and stuff like that. We're going to define our network here with the network mask, right? It's /24. We're going to say the default router, of course, is this IP address here on the router itself. The DNS server 11.6 is going to be over here. And then the domain name is example.com, right? We're in a lab, so we can do whatever we want. Now in the real world, you typically would put your company domain, maybe whatever your company name is, .com or .private, depending on how your company set up their domain name structure internally. Then we have our LAN 11. Remember, we exclude addresses first. Very important to remember. 1 through 15 looks like we save for static addresses. And then we'll have our network command here, default router, DNS server. And that's all the information we want here. We don't need a domain name or anything on this particular one. So when the router receives a DHCP request, it compares the address of the interface it received to the request of the pool's address space. So what that means is when it receives on this interface, it's going to know the IP address of the interface and match that to a pool, right? So because the interface address is inside of this network in the pool, it will know which pool to pull a DHCP address from. So then of course we can show the config, and you'll see we have 3 excluded addresses, ranges. This one's from LAN 11, these ones are from LAN 10. Then you'll see LAN 10 and LAN 11 DHCP pool, just like we configured them there. Now we can verify it with show IP DHCP binding. This is a very important command if you're running DHCP on iOS. You can see the MAC address here, the interface that came on, and the IP address that was assigned to it, and the expiration. This is also very useful. Show IP DHCP server statistics to verify messages are being sent and received. When I was troubleshooting DHCP on Cisco iOS devices, I would usually look at this information here. So you'll see in this case, we have discovers received. We received requests. Where is the sent? There's another command to show this is sent and received there. There should be an offer and an acknowledgement. Yeah, I think it's in another command here. But you can see 7 discover messages were received, only 3 requests were actually received. Now, if you see like no requests received, or your discovers are way higher than your requests, then maybe your offers aren't getting back to the client for some reason. And I've had that situation happen in the past with some security protocols that were blocking some of my DHCP messages. Now you can see in Windows your IP config, and you can see the physical address, the IP address associated with it, default gateway, DNS servers, DHCP server, which can be very important if you have a rogue DHCP server on your network. You might want to check that. Right, so because of the network that it was on, it knew which pool to pull from based on, again, that interface IP address on the router. No DHCP specific router interface is configuration is required. We don't have to put anything on the interface. We don't have to say what interfaces are used in DHCP. It'll automatically do it based on the range we set in our IP DHCP pool, right? And if we need to renew and release our addresses, we can use these commands in Windows: ipconfig release, ipconfig renew. You'll be familiar with those. So if we want to stop DHCP from working, we can do node service DHCP, and to start it, we can do service DHCP. Pretty simple, straightforward. So if we want to restart DHCP, we can this way. If we want to disable it permanently, we can also do this. And it is enabled by default. So with the relay, usually we're going to have a DHCP server somewhere that's going to have some advanced features and some cool functionality. Like a lot of Windows domain DHCP servers are actually going to register DNS for those clients into your Active Directory DNS. It's going to be very, very useful when you're talking about an enterprise environment. So we may have other services, blah, blah, blah. Well, now we have this issue of, well, we've got these people over here on this side of the router. The router doesn't forward broadcasts, it blocks them. So all of our broadcasts will be coming in from this network, right? Getting totally blocked. So there's a super secret command that we use to fix this issue, and that is this IP helper command. Now it's different on other vendors. I've seen stuff like DHCP Relay is typically used because that's what it's commonly called. IP helper, I don't know where it came from, but Cisco came up with that command a long time ago. So you can use the IP helper command, and then you want to specify the DHCP server. And what this does is it converts that broadcast into a unicast message and sends it to the DHCP server you specified here in the IP helper command, and it will send it along and get you a DHCP address. So DHCP is not the only service the router can relay. We can also relay stuff like time, TACACS, which is an authentication protocol, DNS, DHCP, of course. We talked about that, TFTP, and NetPile switch. If you're using NetPiles, I'm really sorry, but you shouldn't be. And this section is really, really short, so I'm going to go through it as well. Configuring as a client, super simple. Just like having our endpoint as a client, we can have our router as a client. This is typically going to be in our small office, home office, with a dynamic IP. that we're given from our ISP. So super simple, IP address of DHCP, turn on our interface, right? They're down by default on a router, and you'll see DHCP address assigned. Now this 6 is not being IPv6, that's just a log level, and we'll talk about that when we talk about syslog, but don't worry about that for the time being, and you'll see the assigned IP address is 209.165.201.12. That's a range Cisco likes to use for their labs, and you'll see a host name of Soho. And so you can show interface in that particular interface, and you'll see address determined by DHCP. Some home routers that are not Cisco can also have this set up, maybe in a GUI, usually in a GUI when you're talking about SOHO type routers. Super simple. So with that, here's some things you should have learned, should be familiar with. If not, go back, review. You should be familiar with these. I wouldn't necessarily memorize all of these, but just remember you can relay other things like maybe time or DNS are going to be the important ones. Here's some commands you should be familiar with. And that's it. So thank you for joining me for this module on DHCP. Join me in the next one. We'll talk about DHCP v6 and how we utilize DHCP or not utilize DHCP when it comes to IPv6. I'll see you then.